Alright guys, so today we are going to be graphing square roots and cube roots. We haven't done this before, so we need to do this now. The best way to graph a line that you haven't graphed before is by creating a table of values. Now with these we want to pick specific numbers for our x values to plug in for the function because we want nice pretty answers. So what I'm trying to say is, if I randomly pick 7 and I do the square root of 7, while 7 is on my graph, graphing this decimal of 2.6 is not the best. So we want to pick pretty answers. So the answers that we want to stick to are like the perfect squares. So 0, 1, 4, 9, those are all perfect squares, right? Now, we have to talk about those cute little negative numbers. So if you take the square root of like negative 81, we have an error. So we can't take the square root of a negative, it's imaginary, so that means it won't show up on our graph. So we don't put those numbers in for our x value. So the x's that we want to choose when we have a square root problem are 0, 1, 4, and 9 because they're perfect squares. And that's when nothing else is on the inside of your radical. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. The next thing we're going to do is graph our ordered pairs. So we have a dot at 0, 0, 1, 1, 1, 2, 3, 4, 2, and then 9, 3. Then we connect our dots, and this is what the graph would look like. Now, if you were able to see it extended out more, you would see that, oops, oh heavens. Okay, so like this, what's going to happen is over time, this line is going to slowly go up, but it takes it a while, and it doesn't go on any of the quadrants of the graph, okay? And then even if we go over here and then we zoom out, you can see that it's still, come on man, there we go. You can see that it's still growing, but it's slowly forever and ever and ever. Alright, so this is the parent function. It's just the basic number with the square root. Or if you just had the basic number with the cube root, like number 6, this guy is a parent function too. All these other functions are variations of it, so they're different types of it, which means I've transformed these other functions from the parent function. Okay, so this is the original function, this is what it should look like. By adding different numbers on the insides or outsides or putting negatives, I'm going to change this graph a certain amount. So we're going to notice what those differences are as well. Okay, for number 3, I'm going to use my same numbers that I used for number 1 because I have perfect squares, so I'm going to do that as well again. Hold on. So on number 3, we're going to use the same values that we used for number 1 because we just have that perfect square root on our table. So we don't have anything else underneath the radical, so it's good to use the numbers that we know will make us pretty answers. Okay, so we're going to use 0, 1, 4, and 9. So the square root of 0 is 0, and then we have to add 3, which gives us 3. The square root of 1 is 1, and then we have to add 3, which gives us 4. The square root of 4 is 2, and then we add 3, so that gives us 5. And the square root of 9 is 3, and 3 is 6. So these are my ordered pairs. We're going to graph them. 0, 1, 2, 3. Then we're going to see how we change from the parent function to this guy. We got 4, 1, 2, 3, 4, 5, and then 9, 6. So they look fairly similar, but this guy got shifted up 3. So when you add 3 at the end, not underneath, it will shift your graph up, and if you were to subtract, it would be down, okay? So we just shifted the graph up a little bit. So on number 5, we already know that if we add a number to the outside, it's going to shift our graph up, but now we're trying to figure out what's going to happen with that cute little negative. Since I just have a square root underneath my radical, I'm going to keep my same numbers because I know they'll give me pretty answers. So 0, 1, 4, and 9. So the square root of 0 is 0, but I have this negative. So this negative on the outside is technically negative 1 times the square root of x. So negative 1 times 0, negative 0, I guess? I don't know. We know that it's nothing. Okay. Then the square root of 1, sorry. Okay, so then the square root of 1 is 1 times negative 1 is negative 1 plus 2 is 1. Then the square root of 4 is 2 times negative 1 is negative 2 plus 2 is 0. Then the square root of 9 is 3 times negative 1 is negative 3 plus 2 is negative 1. So these are my new ordered pairs, and you can always just like plug this in here. So if you wanted to, you could take negative square root of 9 plus 2 in your calculator and you'll get this answer. Okay, so then we graph our ordered pairs. We've got 0, 2, 1, 1, 1, 2, 3, 4, 0, and 9, negative 1. And then we're going to connect our dots. Okay, so from the parent function, this one's kind of like the parent function, but anyways, we moved up 2. And then if you notice the way that this direction was, because it was very similar to our parent function, it just flipped it. So that cute little negative in the front flips your graph. Okay, now let's look at number 2. Okay, so on this problem, I want to make pretty answers. It's really hard to graph decimals. In order to make pretty answers, I need to think about what I want inside of my radical. So my numbers with my square root that I want to keep are 0, 1, 4, and 9 because they will make pretty answers. So in order to pick an x value, I want an x value in here that will make 0. So I have to do the opposite. So I'm going to add my 1 to 0, and that gives me 1. And then this answer will be 0. Okay? So what I'm doing is I'm thinking ahead. I want to take the square root of each of these guys. Oops. Took away my 1. I want to take the square root of each of these guys, so I have to make the inside match. So I want the inside of this, x minus 1, to equal 0. I want this to be the same. So I have to think about, well, what's the opposite of minus 1, which is add 1. So 0 plus 1 is 1. So then when I take this x value and I plug it in, 1 minus 1 is 0, and the square root of 0 is 0, which is exactly what I want. So I'm going to do the same thing with 1. I want to take the square root of 1, so I want this guy to equal 1. So I'm going to add 1 to my 1, which is 2. So if I plug 2 in for x, 2 minus 1 is 1, and the square root of 1 is 1. And that's what I want. Same thing with 4. I want to do the opposite of minus 1, so I'm going to add 1. 4 plus 1 is 5. And then I'm going to plug it in and make sure it works. 5 minus 1 is 4. The square root of 4 is 2. Then I want to do the same thing with 9. I'm going to do the opposite of minus 1, so I'm going to add 1. 9 plus 1 is 10. Then 10 minus 1 is 9. The square root of 9 is 3. So these are my pretty answers, and I just want to avoid the decimals as much as possible because these are much easier to graph. And they give you a better definition of what the curve looks like. Okay, my x value is 1, 0, 1, 2, 1, 2, oops, heavens, I went too far. 1, 2, 1 right there. 2, 3, 4, 5, 1, 2. And then 10 is over here. 1, 2, 3. So like, uh-oh, I forgot it. This way. Okay, so that's what my graph looks like. Okay, so you'll have to do the same thing on number 4. So when you have a number on the inside, it shifts your graph left and right. Because if you look at this function versus the parent function, I started at 0, 0, but now I started at 1. So you actually do the opposite, and we move right 1. Because negative 1 usually means to the left, but when it's inside like this, it ends up shifting our graph to the right, just like we did. Okay, it's the same idea with cube roots. Let's look at number 9. But cube roots are a tiny bit different, okay? So the first thing that you need to know about cube roots is those numbers that we had before are not going to work. Because if we think about perfect cubes, well, if we had 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. Well, that guy's not going to fit on our graph. So these are the numbers that we're going to look at. But you also have to remember that cube roots are different than square roots. And the difference is that we can take a negative cube root answer. So if I took the negative cube root of 81, actually let's do it pretty. I'll make a pretty number, 64. Okay, then you actually get an answer. Oh, there it is right there. Okay, unlike the square root of 81 is an error, but the square root of a negative number, the square root of a negative number is an error, but the cube root of a negative number is not an error. It's an actual number. Okay, so that means that we can do that. So in our cube roots, we have to include our negative numbers. And what negative numbers are we going to include? The negative numbers that will fit on our graph. So negative 1 cubed is negative 1, and negative 2 cubed is negative 8. So these are the numbers that we're going to include. Okay? So with square roots, we wanted our numbers to be 0, 1, 4, and 9. But with cube roots, we want our numbers to be negative 8, negative 1, 0, 1, and 8. These are the numbers that we want to take cube roots of because they are pretty numbers. Okay? So again, we have to do opposites in here. All right, so I want this on the inside to be negative 8. So if this was negative 9, and I added 1 to it, I could get negative 8. Then the cube root of negative 8 is negative 2, plus 3 is 1. Okay, so I'm just trying to think backwards, just like we did on the other side. So I want this inside to be negative 1, and I have a plus 1. So whatever I add 1 to, I need it to be negative 1. So that would be negative 2, because negative 2 plus 1 is negative 1. So that's negative 1, and then I'm going to add 3, and I get 2. Okay, the same thing with 0. So I need a number that will add to 1 to give me 0. Well, that's negative 1. Negative 1 plus 1 is 0, and the cube root of 0 is 0, and then I'm going to add 3, and that's 3. And the same thing with 1. So if I have 0 plus 1, that'll be 1, and the cube root of 1 is 1, and then I'm going to add 3, so that's 4. And then my 8, the same idea. So 7 plus 1 is 8. The cube root of 8 is 2, and 2 plus 3 is 5. So these are my ordered pairs. This is really kind of tricky at first, but you'll get used to it. So I have negative 9, 1, and negative 2, 2, and negative 1, 3, and 0, 4, and 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. Okay, so really similar to square roots, cube roots kind of go up and out, but then they also go the opposite direction, up and down. Man, I'm really sorry about all of the announcements. Okay, so here, I'm going to graph it for you. Alright, so then it's x plus 1, just so that you can see, plus 3. Okay. Oh, darn it, I zoomed out too far. Hold on. It's hard to see. Okay, zoom, standard. Alright, so this is what a cube root function looks like when you graph it. It's kind of bananas. And if you wanted to see it just like the parent function, it looks like this. Okay. Oh no, I messed it up somehow. Hold on. 1y. Oh, I left that guy in there. Okay, graph. So this is what the parent function of a cube root looks like. It goes through the origin just like our square root did. So it has our square root on the other side, and then basically it just flips it and goes the opposite direction to include those negatives. I mean, they're slightly different because you can't have, like, a square root of 8 isn't pretty, but the cube root of 8 is, so they're slightly different, but the same idea. All right, let me know if you have any more questions. You have another day of this tomorrow. I hope you have a great day. Bye, guys.